Hello there, welcome to question number 7 of the revised GRE general test. Now the question here says x is the set of all integers n that satisfy the inequality 2 less than or equal to the absolute value of n less than or equal to 5. Now what we want to do is we want to determine which of these quantities here, which one is greater. We want to determine the weight of the two quantities, so we could choose one of the options here. To explain this, let me just give you a very good explanation so we can have an intuition of what is happening here. So now, the absolute value, let me first explain the absolute value here. The absolute value of 3 is 3, and then the absolute value of negative 3 is also 3. So that implies that if you're told to solve say the absolute value of a number equals 3, and then you're told to solve for n, so that simply implies that either n equals 3 or the negation of n equals 3, like we have seen here. So if the negation of n equals 3, then that means n equals negative 3. So that implies that n equals 3 or n equals negative 3 is going to be a solution of this equation here, and you could try that by substituting 3 here. You have 3, negative 3, you have this, just as shown here. Now the question we have here, we want to solve this inequality here. The inequality we want to solve that we're given is 2 less than or equal to the absolute value of n less than or equal to 5. Now this is a combination of two things here. So this is 2, so I'm going to break it down. So you have 2 less than or equal to the absolute value of n and absolute value of n less than or equal to 5. So you could think of this and as the intersection. That is the intersection of 2 less than or equal to the absolute value of n intersect the absolute value of n less than or equal to 5. So let me label this A, and I'm going to label this B. So what I'm going to do now is I'm going to solve this, and then I'll solve this, then I'll draw the graph of their solution set. Then the intersection is going to be the solution of this quadratic inequality. So let me start with B. So for the B part, what we have is the absolute value of n is less than or equal to 5. Now according to what we have here, according to what we showed here, if the absolute value of a number equals 3, it implies that either the number equals 3 or the negation of a number satisfies the inequality, satisfies the equality. So here too we are told that the absolute value of n is less than or equal to 5. So this implies that either n itself, either n is less than or equal to 5, or the negation of n is less than or equal to 5. So if the negation of n is less than or equal to 5, to remove the negative sign here, I'm going to multiply both sides by negative 1. So when you multiply both sides by negative 1, you have n. Now anytime you multiply both sides of an inequality by a negative sign and by a negative number, the sign of the inequality changes. So this changes to greater than or equal to negative 5. So what I have here is, as the solution, is going to be n less than or equal to 5 and n greater than or equal to negative 5. So I'm going to draw that on my number line. So let me choose this as my number line. You have something like this. So now here is negative 5, this is negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. This is infinity, this is negative infinity, negative 6. So this keeps on going like that. So to include the first one, like what we have here, says n less than or equal to 5. So this is 5. So it says equality sign means 5 is included. So I'm going to thicken that. So it keeps on going like this. So let me determine what the next one says. It says n greater than or equal to, n is also greater than or equal to negative 5. So the equality sign here means -5 is included, so I'm going to shade this. So it says greater than, so that means it follows this orientation. So that is to say, since they both meet, so that implies that the solution of this inequality is here. So all numbers that fall in this range satisfies this inequality. And you can check, if you pick -1, when you substitute -1 here, the absolute value of -1 is 1, which is less than or equal to 5. You pick any number, it satisfies the inequality. So that's A. Now let's go ahead and solve for, sorry, that's B, so let's do A. So what A says is 2 less than or equal to root n. So we want to solve 2 less than or equal to the absolute value of n. So I could rewrite this, so if 2 is less than or equal to the absolute value of n, it's the same thing as saying the absolute value of n is greater than or equal to 2. So I've not really done anything, I'm just changing the way they are written. So if the absolute value of n is greater than or equal to 2, according to the example we did above, so it implies that, so this implies that either n is greater than or equal to 2, or the negation of n is greater than or equal to 2. Now when the negation of n is this, to remove this negative sign, I'm going to multiply both sides by -1. So I have n. So since I'm multiplying by a negative number, the sign here changes to this. So what I have here as my solution is going to be n greater than or equal to 2 and n less than or equal to -2. So I'm going to represent this on the same graph. So the solution set says n greater than or equal to 2. So this is my 2 here. So I'm going to draw this. So this is my 2. So the equality sign here says 2 is inclusive. So I'm going to thicken it. So 2. Then the direction says greater than or equal to. So it follows this direction here. So, and then I can shade here. Then I keep on shading. And then the next one says n less than or equal to -2. Now the equality sign here indicates that -2 is inclusive. So this is it here. You have this. So -2 is inclusive. So you have, so it less than or equal to, so it goes in this direction here. So we could just extend this. So that is, the solution is all numbers that falls on the left hand side, and it keeps on going to -infinity, it doesn't stop. So but then our solution is the intersection of both this and this, that is the solutions of the two of them. So looking at what we have here, the intersection is just from here, you can see from here to here. So let me use a different color so we'll see what's happening here. So from here to here, this is where the intersection is for here, and then similarly the intersection is, that is where you have the two colors, that is from here to here. So let's go back. It says x is the set of all integers that satisfies this inequality here. So my x is going to be, that is x is the set of all integers. Now all integers that lies in this range is going to starting from -5 because it's inclusive. So you have -5, you have -4, you have -3, then you stop at -2. So the other one to here, you have 2, you have 3, you have 4, and then you have 5. So that's where that stops. So that means this is the solution of that inequality. Now what the question says is, it says quantity A is the absolute value of the greatest integer in x. Now looking at what we have here, the greatest integer, that is the greatest whole number, the largest whole number is 5. So the absolute value of 5 is 5. So that implies that A is 5. So our A is 5. Now B says the absolute value of the least integer in x. The absolute value of the least integer. Now the least integer is the lowest number. So the lowest number here is -5. And then the absolute value of -5 is 5. So that means B also is 5. So since quantity A equals quantity B, then our solution is going to be or our answer is C, since both quantities have the same weight, and that completes the problem. Thank you for watching.